Okay, so moving into the second page. Okay, so unlike question 6, question 7 is a different question because this is really like saying 5 to the imaginary power of 1 times x to the power of 0. So 5 to the power of 1 will be 5, x to the power of 0 will be 1. So this solution is just going to be 5. Okay, and 8 differs from 6 and 7, whereas 8 is saying you need to uh, use your power rule, power over a product rule, right? So this is like saying 5 to the power of 1 times 0 times x to the power of 1. Maybe I should use a dot so I don't look like xx times x to the power of 1 times 0, which then gives you 5 to the 0 times x to the 0, which is just 1 times 1, which then would be a solution of 1. All right, so 9. Couple different ways to do number 9. I think the simplest way of doing number 9 is to first simplify that fraction as much as possible before you even concern yourself with this -3, right? So 6 divided by 2 is going to be 3, and then x to the 8th minus the 4th by using my quotient rule because this is division, so I can just subtract those and then raise all of this to the -3, which will equal 3x to the 4th, and all of this is raised to the -3. And now again, I can do a couple of ways. I can go ahead and just utilize my negative exponent power, which by just reciprocating this and now making my 3 positive, or I could have did my distributive property, my power over a product property, like either or. But at any rate, this is going to give me 1 to the 27th, cause 3 to the 3rd will be 27, x to the 12th, right? So when I'm using my power rule to a exponent, that becomes multiplication. When it is when I'm using my product rule, I then add the exponents. So looking at 10, so 10 is kind of like 9. We can't simplify anything, right? But what I can do is I can just reciprocate and put the p squared on top and the n cubed on bottom, and then raise that to the -2. Oh, I'm sorry, to the +2, right? And now I can just utilize my power rule. So p to the 4 n to the 6. Now, if for some reason, let's say if you had something like this, n to the -3 over p to the 2nd, and we raise all of this to the -2nd, right? I'm gonna still work my negative power over a product rule and still say this becomes p to the 2nd over n to the -3rd, and all of that raises to the +2nd, right? And now I can do my negative exponent rule where this becomes p to the 2nd n to the +3rd, all raised to the 2nd. And now I can do my power over a product rule, p to the 4th n to the 6th. So just kind of showing you some different ways in case, they switch up the problem just slightly on you. All right, so question 11 is just going to use my product rule, right? So I have basically x times y to the 4th times parentheses 6x to the -cube y squared to the -3, right? And so this time I'm going to just use my negative exponent rule instead of reciprocating this because then it'll give me fractions. So this is going to become x times y to the 4th times 6 to the -3 times x to the +9 times y to the -6, right? So now I'm going to rewrite this where I'm going to put the numerical value in front of the exponent so I can have a coefficient. So 6 to the -3 times x to the 1st plus 9 times y to the 4th plus a -6. Right? So then I get 1 over 216 x to the 10th y to the -2nd, which gives me a final solution of x to the 10th. Why did I write x to the 2nd? I'm saying x to the 10th x to the 10th over 216 y squared. All right, question 13 and 14 is converting to scientific notation. And so remember what scientific notation looks like. That's just basically saying k times t raised to the n, where k is less than 10, but bigger than or equal to 1, and n equals an integer, meaning it can be positive or negative, right? If it's negative, it's just going to the left, meaning it's smaller than 1. If it's positive, it's going to the right, meaning it's bigger than 1, right? So that's one good thing about the base 10 system. When you get into scientific notation, it's just multiples of 10 or divisions of 10, right? So first thing first, when we get this number 0.000056, first thing we got to do is make this number between 1 and 10, right? So I'm going to move my decimal 1, 2, 3, 4, 5, 6. So I get 5.6 times 10 to the negative, forgot how many times. So 1, 2, 3, 4, 5 to the negative 6, right? And it's negative because this number is smaller than 1. If it was bigger than 1, it would be positive, right? So if I wanted to check that on my calc, I can just say 5.6 times 10 raised to the negative 6. Now this is so small, it's more than likely going to put it right back in scientific notation, right? So you got to understand that when you see this on your calculator, right? When you see this e negative 6, that means it's in scientific notation. That's basically is telling you that this number is so small, the calculator is telling you it's times 10 to the negative 6, right? So at least we know we are correct by getting the exact same solution. All right, and then lastly, we have 67 million, and we need to put this in scientific notation. So again, I'll move my decimal 1, 2, 3, 4, 5, 6, 7. So I get 6.7 times 10 to the 7th, right? 10 to the positive 7, because 67 million is obviously bigger than 1, right? And so again, if I check it on my calculator, 6.7 times 10 to the power of 7, we get 67 million. All right, so we'll finish up this last page in the next video. Talk to you shortly.